All right, welcome back. We are Game 3001 in the summer 2020 semester, and it's week 10, lab part 2, the solution. So in the last video, I kind of gave you guys a challenge. I said, hey, can you make, our little plane kind of chase around the outskirts, and I'll show you what I got. I kind of put together a solution in a second, and I'll run it. So this is my little plane. I moved my plane into position. I've got my player in a position, so you can see that I've got, right now there's no line of sight. And if I press the P button, then we'll see that the plane is starting to patrol. You can see that the plane is patrolling. And I've also changed the direction of the plane. Now you don't have to do it this way. All I need is for the plane just to move around for the lab. But the great thing is, no matter where I move the player, it's going to have this connection, almost like a tether, that goes between the plane and the player, and also it's going to update the line of sight up here, as well as update the line of sight for my connection between the plane and the player. So that's kind of how it goes. If I press P to stop it, no matter where I stop it, it'll kind of stop the patrol mode. It'll only work once, and I can stop it at any point in its journey. All right, so that's kind of how it works. That's the pause mode, which takes care of one of the requirements of your debugging, right? So it says if I press the debug keys and if I actually press the P key, the base enemy's movement will be toggled between idle and patrol. Okay, so I kind of made it happen. I didn't set up states for the enemy. It doesn't tell you that to do that anyway. And one thing is, in the enemy's requirements in the bottom, so if I go down to the base enemy, it says the base enemy will move and patrol along a predetermined path of nodes around the map. That's what I've made it do. It doesn't mean that right now the enemy is moving by a state. It's just literally I made it move around the map. So that's what I kind of made it do. Okay, so that's what this is. And let me talk about how this works. First, before I go there, I'm going to see if I can get this up on Blackboard, because I want to make sure that people who are watching this won't be too mad. But it just, Blackboard has a funny way of not accepting YouTube videos all the time, so I may not be able to put it up on Blackboard for you guys right away. It may have to go up later. I do apologize about that. It's not my fault. It's a Blackboard thing. So if I go here and I paste in the web link, there it is. And then sometimes it'll work, and well, sometimes it won't. So hopefully you guys are watching this, the solution. All right, let's take a look and see how I did all that stuff. So first thing is, I started by putting some stuff in the playscene.h. So I figured I needed a couple things. I need a patrol path, right, vector. So this is the patrol path vector, which is going to be a vector of nodes that I'm taking off of the path. So the grid itself, I've created a grid. I'm just going to select my nodes and plop them in the path, just as pointers to the to the grid that I have there. That's the first thing I did. I need a few methods. The first one is I want to build my clockwise patrol path. So I decided to go clockwise, not counterclockwise or anti-clockwise or whatever you want to call it. I also built in a debug method that allows me to print my, display my path to make sure that it's the correct path. Right, so that's what I did there. So first things first, let's not do this part. That's the part that's going to happen next. And I'm just going to do these two pieces. So let's look at build clockwise patrol path. Go to definition. All right, so basically it looks like this. I have a bunch of for loops. And now you don't have to do it this way. You could actually hard code it. So let's say, as an example, you decide that what you want to do, 8 errors. Hey, yeah, there's errors because I commented some stuff out. Let me put that back in for a second, and then I'll just talk about it, and then we'll get there. So yeah, so I'll go to definition for build clockwise. Yeah, so what I did was, again, I decided to go clockwise. You don't have to. And what I did, I ran 4 for loops, actually, really kind of odd, that allowed me to build up my patrol path. Remember, my patrol path is a vector. Now, you don't have to do this. You could have listed it longhand. You could have said, okay, I want this node, this node, this node, and this node, and these are the positions. I mean, literally, you could have put positions, a group of vec2s and a list. You could have done it that way as well. You could have made use of an array. I mean, there's lots of ways to to do this thing. It's not just one way. I decided I already have a set of path nodes. I want to use them. I just want to, kind of make a pointer to the patrol path that goes around in a clockwise direction. Now, it doesn't have to be this way in any way, by any means, okay? So how did I do it? I said, moving to the right, I'm going to do a for loop. It's a for loop that starts at 0 and up to the column number. So what I'm doing is I'm saying, okay, so I'm going to go from the entire column. I'm going to march around to the right of the column, move from left to right, and I'm going to push back the first column, the entire first column from left to right. This was the easy one, moving right, okay? So that's the first thing I did. So that adds all the grid locations from the top left corner to the top right corner, the top line basically, into my patrol path, okay? Vector. And then the next thing is moving down. Moving down is a little trickier. So I start off with my column number. So my column number is 1 to 10, right? So I have up to 10. So 10 columns, right? Multiplied by I being a number between 1 and row number. I started at 1 because I don't want to start at the top right column anymore, right? I want to start at one column below. If I want to start at the top right column, I would duplicate. It would pause. It would kind of go to the top, pause, go to the right, pause, go to the bottom, pause, go to the left, pause, and it would do that, a bunch of times. But that's not what I want to do. I don't want to pause. I want to move from one place to the other. So I'm going to start at 1, so 1 below the top right. So what this means is I'm going from 1 to row number. So from my first row number, my 0th row number I've already done. I've already got the first line done. But then my second row, which is the first row, right? Because we're using zero-based counting. So down on row 1, I'm going to take that from 1 to row num. Row num being less than row num, which is there's only 7 rows. That means it's going to go from 1 to 6. That's what it's going to be. So 1 to 6, from row 1 to row 6. So starting at row 1, take 1 multiplied by the column number. Column number is 10, so that's 10. That's the index. So I'm using this, instead of using a multi-dimensional array, I'm using a single-dimensional vector, so that I can just index it this way, right? I'm adding my column number. So I'm multiplying, first of all, multiplied by the column number. So now it's 10 plus the column number that I'm at, right? The total number of columns, which is, again, 10 minus 1, 9. So it basically says, okay, so take 10 plus 9. So that's 19. So that's the rightmost column. And then I move to the next one, 2 times 9, right? So 2 times 9, or column number is 10. 2 times 10 is 20, plus column number minus 1. So that's 29, 39, 49, 59, and then finally 69. 69 is the bottom right corner. That's where that is. Okay, so that's 69. So it goes from the right, then it goes all the way down to the bottom. And then similarly, going left was more of a challenge, right? So again, I would start off, and this time I'm doing 1 to column number, right? So again, I'm going column-wise. If I do column-wise, if I go across, I go 1 to column number. If I go down or up, usually I do something with a row, right? So row-wise. So I'm doing column-wise this time, going back this way. Okay, so I'm marching back. To march back, I could have done a decrement, kind of a for loop that decrements, but I subtracted instead of adding. So I started with column number times row number, that's the bottom right corner, that's what that is, minus 1, so that hops me back 1, minus I. So as I starts, it starts at 1, so it goes 1 back, and then it keeps counting back, counting back, counting back, subtracting for that number across the bottom of the row until I get back to the bottom left corner. So that's moving left. And then moving up, what I did was the same thing. I started off with, in this case, I'm decrementing. So I'm starting off at row number -2 because I already have the top row and I already have the bottom row. So I can subtract those two positions, right? And then what I'm saying is when I is greater than 0, as long as I is greater than 0, I minus minus, all right? So I start off, row number, which is 7, -2, right, is 5. So 5, so I put 5 in there, multiplied by the column number, right? So my column number starts off with total number of columns is 10, so that's 50. So that's down here, right? And then I go 50, 40, 30, 20, 10, and then I never go to 0 because what's happening is 0 is the top left corner. All right, so that's what I do. I march up this way. So that is how I added my path. I just marched to the right, marched down, marched left, and marched up, and I had 4 for loops to do that. Could I have done it differently? Absolutely. Could I have just listed all the, there's not that many positions. I mean, really, there's 10 across there and 10 across the bottom. And then we've got, you know, kind of 5 this way and 5 that way. So you're looking at a total of 30 different positions. I could have listed 30 positions here and be done with it. But I figured I'd calculate it instead. You could also load this from a file. There's lots of stuff you could do here. So that's build clockwise patrol path. You can make your patrol path in the assignment any way you like. You can make a patrol in circles, do some kind of weird zigzag pattern, whatever you want. Okay. I want to display my patrol path now just for testing purposes. So what I'm going to do is I've commented it out, but I want to show it. So let's show my patrol path to test this. I did this one just to test to see if the numbers make sense. So all I'm doing here to test my patrol path, to display it, I'm just going to loop through every node in the patrol path and then output the X and Y coordinates. That's all I'm doing here. So you don't have to do this. This is for my testing. This is how I confirmed that what I'm doing is correct. Okay. So notice, if you notice, I've got all these nodes in the patrol path. This is what I want. So 40, 40 is the top left corner. Then I go to 120, 40. Looks right. 120, 40. 40 is the y-axis, right? 200, 280, 360, 440, 520, 600, 680, 760. And that's 40 away from the edge, which makes sense. So that's the top. And that we knew the top one would be the easiest one, right? 760 and 40. Then we start going down. We still say it's 760 and we go 120, 200, 280, 360, 440, all the way down to 520. And that's the bottom right corner, 760 and 520. And then we keep 520 on the y-axis, but we march back on the x-axis, 680, 600, 520, 440, until we get to 40. So 40, 520 is here, approximately on the left corner, right? And then we go 440, 360, 280, 200, and all the way back up to the top. And we keep doing that over and over again. So that's how I do this. And I can comment that out again. So I don't need that. That was just my debugging. That was for me to confirm that I'm getting the right numbers, right? Otherwise, you know, maybe my clockwise patrol path isn't going to work properly. If I was going to go anti-clockwise, then I would have to change the indexing, right? So I would look at each one. I would march to the left, right, as an example. So I would put that the way I'm marching to the left. I could put that at the first, you know, march to the left, and then maybe I'd start at the bottom right, march to the left, you know, at the top, march to the left, march down, march across, march up. Marching across again would be easier because I'm going to the right. Marching down would also be easy. In fact, maybe doing an anti-clockwise spin would be easier in many ways than doing a clockwise direction. But anyways, we digress. So that's that one. That's that part. So that is configuring the patrol path. That's the number one thing that I want to do. The next part. Once I've got this done and I've displayed it, I want to start thinking about how to figure out the target node, right? So one is I want to keep track of my next node index. Remember, my patrol path is a vector, you know, of let's say 30 nodes that I'm going to walk in my case, right? 30 nodes. So I start at node 0 and go to node 29. And then at the end of 29, I'm going to go back to 0. I'm going to loop somehow. So I got to start off with some kind of target path node index that I have here. Now this could all have been inside of my my plane, right? But instead I just put it inside of my placing.h because I wanted to make it work today, right? I could always port this over to my plane if I want to. All right, so here's the next one. So my target path node index starts at 0, and what I do is in my placing.cpp, as an example, in the start, I started actually at 1 because we're already at 0. I start my plane right in the top left corner, and the top left corner is the 0th position, right? So I want to go to the first position. That's the next position, which is over here, right? So that is the next position on my path, right? That's where I want it to go. So that's what this does. Target path node keeps track of that, okay? And then what I want to do is I want to create my target path node. Now there's a bit of figuring to do this, and I'm going to use something similar to what we did in the first half when you did steering behavior. I'm using kind of a steering behavior to do this, to steer me along the path. That's what this is going to do. All right, steering behavior. So target path node. And then I'm going to use this method. I made a method called move plane to target node. That's what it does. So every frame, it's going to keep moving the plane to target node. And then when I get to the target node, I'm going to increment my index, my path node index, to the next one, the next one, the next one, the next one. Okay? So that's what this does. So let's take a look at move plane to target node. This is where all the work is being done for me to actually move my plane. This just calculates the path. What is the path? This shows the path. This moves the plane along the path. Okay, so let's take a look at this one. So go to definition. All right, so this is a bit of a bigger one. Again, I coded that just today and where we were waiting. Let's take a look. So first, I want to check to see if my patrol mode is on or off. Remember, when I press the P key from last week, I can turn patrol mode on or off. That's what this does. Okay? If I press P, patrol mode turns on. If I press P again, patrol mode turns off. So if it's on, then I want to do this stuff. If it's off, I don't want to do this stuff. Pretty simple. All right, then I want to calculate my target path node. My target path node is my patrol path vector, and I want to use my target path node index. This is going to return a path node vector, pointer, a pointer to the next path node. That's what this thing does. All right. So the first one is the second one in line, the second one, the path node number 2 equivalent. Okay, because this is 1. Path node starts at 1. It's going to go to the second place in my list. Okay. Okay, here's the next one. Target vector. My target vector, what I did was I used something called Normalize. And what I did was I got the difference, and this is what you should have done in the first half. I got the difference for pathfinding, for steering behavior, for seeking. I got the difference between the position of the plane, so where is my plane sprite, as an example, and I subtracted the plane from the path node, right? Subtracted one from the other, right? So my target path node, I subtracted it from the plane. All right, now it doesn't really matter how you did it. You could have done it the other way around as well, right? As an example, but basically what this does is it creates a vector, which gives me it's a normalized vector. Normalizing, if you look at the utility function, go to definition. I'm moving towards the right, right? It's going to take a vector, and it's going to take the total length of the vector and divide it by, it's going to normalize, it's going to make a unit vector. That's what this returns, a unit vector. Otherwise, if I subtract one from the other, it's going to give me a very, very long vector, and I don't want that. I want a unit length, a vector of unit length. All right? So this is good. So that's what this does. So if I go back to my placing. So this returns a vector of unit length. Okay? So I got my target vector. Once I get my target vector, it's just going to give me the direction. And this means that there's a few options for this one. So my target vector is either going to be 1, 0, right? Or it's going to be, when I go to the right, it's going to be 1, 0. When I go down, it's going to be 0, 1. When I go left, it's going to be -1, 0. And when I go up, it's going to be 0, -1. Those are the four options that my target vector is going to have. So in different directions. Now, if I had another position, let's suppose I load another position in my path, somewhere in the middle, right, as an example, then it would be different numbers, okay? It would be a different number here. But that's not the case. So the case is there's just corners that's happening. So that's why I'm able to test for this. So now I can test. I can say, well, look, if my target vector x, my target vector, which is a GLM vec2, right? If it's 1, if it's positive, then I want to set my angle to 90 degrees. Now, the plane sprite did not have this set angle method. So if I go there, go to definition for my plane sprite, I added it in. I said, hey, my plane, let's add an angle, a float angle, and set angle as a method, a setter, to set the angle of my plane to whatever I want, okay? And then in the draw function, after I set the angle, in the draw function, I'll add in the angle in the draw function. So when I set the angle, it'll change the orientation of my texture, the texture of my plane itself, so it points in the right direction. That's all it's doing. It's not actually rejigging the colliders or anything like that. It's just pointing in the right direction. Okay, that's what it's doing. So that's what rotation does. This rotation actually rotates it in degrees, and it starts at 90, 90, 180, as an example, and then negative 90 if I go this way, and then 0 up. Okay, that's what happens. So that's what these things are, and I did that here. So I said, well, look, if my target vector x is 1, so this case, and this is moving towards the right, then I want to change this to 90 degrees. I want to just angle the texture. I want to change the angle of the texture so it's 90 degrees to the right? If it's negative 1, then I want to flip it the other way, right? Negative 90, right? And so on. So that's what changes the rotation of the plane. And then I do some funny work with my rigid body. So I say that my rigid body, my velocity, is equal to my target vector. So I set my velocity as the target vector. Whatever the target vector was, now my plane's velocity is that target vector. Why? I want to capture the new target vector every frame. If my target vector was changing, or if my target was changing, then the target velocity would change as well. Right? Velocity, remember, is a vector that has both kind of a direction and magnitude and direction, right? So my target vector would be, again, my velocity would be a unit vector, 1. It would add up to 1, and again, in one of those 4 cases in this case, right? That's what my rigid body would be. Okay, then I want to update the position of the plane by adding the velocity that I just calculated, which is my target vector. By the way, I could have just put this here and not keep track, but I just wanted to keep track of my velocity, multiplied by the max speed. Okay, so where did I get this max speed from? Well, I set it down here. I said max speed is 5. You can set the max speed to whatever you want, as an example. I also, by the way, I also changed the plane sprite to the top left corner, so here, and I also changed the player to a position that's around 600 and 440, which I figured out was that spot on the screen, which is right here, which is on top of this node. I just made that calculation quickly. I could have used the node too, but I figured I just, I want to go to that particular node right there. All right, so that's what I did there for this one. So I changed the player's position as well as the plane's position, and then I set the max speed to 5. 5 pixels per frame is what this is going to move. I can make this slower or faster, no problem, by just changing this value. Cool, so now I have my max speed. I'm moving every frame. As long as my path, my patrol mode is on, I'm moving across the path. And then I do a check. I say, look, if my position, my current position, my plane's position, is equal to the position of my target, right, my target path node, then I need to increment my path node to the next one, and the next one, and the next one. And when I increment my path node, when I come back up here, I'm going to recalculate my target vector every time I come up. So when I do that angle, if I go to the top right or the bottom left, it's going to recalculate my target vector and also rotate my plane in the right direction. That's what it's going to do. Okay. So I'm going to increment my path node, and then I'm going to check to see if my target path node index, so if this index is beyond the size of my patrol path, then -1, then I'm going to set my target path node back to 0. So this is going to flip from the bottom of my path, so the end of my path, to the beginning again. And it's going to just basically go over and loop through my path. And that's how I did it. That's the entire piece of code. All right, so again, how it works is when you press H to turn on my debugging, you can see that there is no line of sight, and we also have no line of sight for these nodes because of where my player is. You can see there's no line of sight for all these nodes and these nodes here. It would have been nice if I moved my obstacle in here or resized it properly. I didn't. But if I press P, then you can see that it's going to run to the right, and you're going to lose line of sight once it goes behind the obstacle. Right? As soon as it goes behind the obstacle, this line is going to turn red, and you're going to lose line of sight every single time. And that's how it's going to work. Pretty simple stuff. Right? If I stop pressing P, it'll stop wherever I've got it. Patrol mode off. Patrol mode back on. Patrol mode off. It'll stop the plane exactly where it's going to be. And I can do my test this way. Okay, so that's kind of the state of where I'm at. That's the end of the solution. So, questions? Did you guys think about doing this differently? As an example, would you have done it the same way? What are your thoughts? And let's see if I can actually get that stuff on Blackboard so people who are watching are going to be actually able to see this thing. Yay, it's going to work now. What are your thoughts, guys? There, it's up on Blackboard finally. I was like A10-2. Yeah, I know. You know, you could do... you could use v cos theta, v sine theta stuff. Basically, that's calculating the next pixel, but it's much easier if you just use a normalized vector, which is the way to go. You just subtract your target from your. By the way, if I was to do it the other way around, let me show you what this does. If I go back, and I think I even made a mistake in my calculations. So here, my target path node, right, is this, but my target vector should be my target path node minus my plane's position, not the other way around. I did this in the wrong order. Right, let's see, does that make even a difference? If I just did this and I subtracted, if I said take my, actually no, I did it right. Sorry, what am I thinking? I totally did it right. I took my target path node minus my plane. So that's, you get this negative number, right? So you kind of, if my target path node is over here and you subtract the plane, you're going to get the direction of where you're looking. That's what this does. I actually did it completely right. So this is the key, this target vector here. And you guys should have learned that in the first half of semester, where wherever I'm looking, I take two vectors and I subtract the target vector from my current position and I get the direction. But my direction line is going to be really long. If I just left it without normalizing, if I didn't get the unit vector here, then I would be drawing a line. The magnitude would be the difference between my current position and the position that I'm aiming, my target position, which would be a very long line. And if I took that and used as velocity, I would snap to that position immediately, instantly, right? Which is not what I want. I want to go to that position. And in order for me to go to that position, I'm going to take my velocity and multiply it by my speed, right? So that's what I want to do. Now, if I can speed up or slow down by changing my max speed. So if I say something like, well, my max speed is 1, let's say. Okay, so I want to really slow myself down. I can change my max speed here to 1. And when I do that now, if I press patrol mode, so press P for patrol mode, you can see that it's going to patrol really, really slow, right? It doesn't look terrible, right? And again, once it hits that corner, it's going to, rejig itself to go down, which is kind of cool, right? So number of nodes, 70. This little check here is checking how many nodes I have on the screen here at the same time. Those are all the nodes that I have, right? Okay, so that's kind of how it works, right? Pretty good. So you can change these numbers, whatever you want. I just used 5 because it was a decent number, but 1 is just as good. It'll keep patrolling around. Here's another thing. What you can do is you can add in additional path nodes. Let's suppose I don't like that there's only this many and I want some other weird pathway to go through. So when I'm setting up my grid, right, which is build my clockwise patrol, let's suppose I want to be crazy and I want to add in another one between these two. I want to pop over to one thing and then pop into something else. So when at the corner, like down here, I want to kind of go up and then go back and then go over and some weirdness, right? So what we need to do is calculate what that value is. If, let's say, for example, I want to go to here, and then I want to go here, and then there. So I want to add this extra node right here. So how would I do this? How would I calculate where this is? Well, we know that this is 0, 0, right? So from a grid position perspective, this would be 0, 1, 2, 3, 4, 5, 6, 7, 8, right? And this would be 0, 1, 2, 3, 4, 5. So 8 and 5 from a grid position. Plus some adjustments in terms of our centers, right? So if I wanted to go 8 and 5, 8 times 8, as an example, right, because it's 80 wide, is 640, but that would be at the left corner. So this would be 640, 8 times 8, plus 40 to get to the middle. So 640, that's 680 pixels this way, right? And then I'd want to go down here, 680 pixels. I want to go down here to where that is. But that's not the thing, not the position. I don't need that. I need this 8, as an example, by 5. So again, 0, 1, 2, 3, 4, 5, 6, 7, 8, and then 0, 1, 2, 3, 4, 5. So I don't have a way of addressing this in my node, my path nodes, right? 8 by 5. 5 in the grid, right? For me to calculate 5 in the grid and 8, I would take the row number 0, right, as an example, and then I would go down to 0, 1, 2, 3, 4, 5, right? So I would go down 5. That would be the first thing, row 5, right? Multiply, and I would add, multiply by the row width, right? So 5 multiplied by 10, because there's 10, that's 50. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, 30, 40, 50. So I'm here, right? I'll take 50, right? And that's how I would do it. 5 times 10 is 50. Plus, I would add in the number here. 50 plus 1, 2, 3, 4, 5, 6, 7, 8. 58. So if I said number 58 to go here, this would be 59. So let's try that. Let's add 59 in there, manually. So if I want to say that, I want to say something like m_p patrol path dot pushback, and I want to look at the m grid 59, right? So how would that look? It would look weird. It's going to look weird, right? But I say I want the 59th index, right? The 59th element in my array, right? In my vector, right? That's what I want to push back, and it's kind of out of order. And by the way, it's going to look funny when it moves because it's not going to be in the right target direction. Let's see how that works. So I've got an extra node in there, right? That's what it's going to do, and let's see what happens, right? So turn it on, and for the first part, it's going to go fine, but then it's going to get squirrely later on, as you're going to see, right? And let's see what happens. So it turns, boom, really like rough. And then when I go down to the right, I'm going to hit the bottom right corner, and then it's going to flash up to this part. Right? Whoa, wait a minute. What happened? How come it didn't add to that direction, right? If you notice, right, as an example, I didn't get that that happened. Oh, I actually did it, but it was the wrong one. I did in the wrong order. So it actually did that. So there's finding that path. And then from there, it's going to head back to the other side, right? And it's going to mess up because it's going to like, wait, I don't know where I am. It's really weird, right? Yeah, because I've totally messed up. Let's try that again. But it did go in that direction. It just never made it there. So what's happened is the way I stop it, remember, it's not using arrival. It's just using numbers like, hey, when I get there, right? Which is what I'm saying here. When, for me to stop moving, right? So move my plane. For me to stop or increment, I want to check to see that my position is exactly equal to what I'm looking at. It's going to equal. Well, this is never going to be equal. That's why this isn't going to work, right? I'd have to say it's got to be close. It's going to be less than, 0.1%. If I take these two, subtract them, they should be within some kind of absolute value of 0.2 or something like that. It's going to be close, but it won't be exact. That's what's going to happen if I did with the way I'm doing it. And the reason why I messed up, I kind of had the right idea, but I did it in the wrong place. So I kind of said, hey, let's add that, let's add 59 here, but it shouldn't be here. This is moving left. I should do it before I move left. I should move it after I move down. That's what I want to do. So I want to do it here. Now it's still going to mess up. It's absolutely going to mess up because I'm going to go in a weird direction and I'm probably going to miss it. I'm probably going to go overshoot, which is what steering behavior does, right? It doesn't exactly go on top of it. It was working before because I'm going in a very, 90-degree angles. I'm moving at right angles, so that worked. But this won't work. You have to use arrival. You have to use some other methodology to get there, right? So let's take a look and see how that works. So again, and let's make it a little faster too. So because we're going to wait for it, right? And when we make it faster, that's even going to be a bigger error because of it's going to overshoot by 5. All right, let's see how this works. So here it is, and let's go. Right, so it's going to go down here, and once it goes down to here, it's going to try and go here, and right, and it's going to just fail, right? And by the way, 59 is wrong, right? Because I just figured that out because it would be 58, not 59. So we went back up is what we did. We ordered it in, so we said, hey, once we're there, go back, right? No, this should be 58. Let's try one more time. And again. We could, theoretically, if I wanted to make a grid class, I could do it so I could use my own custom index. I'm not doing that here. All right, so again, let's try it. And you can see I want it to go there. And there we go. And now it's going to stop. And the reason why I didn't quite make it and it's going back and forth is because it's close, but it's not really on the money. And that's why it's doing this jittery thing. It's close, but it's not quite there. And the way to take care of that, if you wanted to use this, is if I'm close, so I'm saying here's my position, my actual position, here's the my target position. If it's within a few pixels, like 2 or 3 pixels, I can do that. I can say take the absolute value of this number, right? If the absolute value of this number, so this minus this, whatever it is, if the absolute value, right, and again, I want to use absolute, where I'm getting the absolute position in terms of x and y, and I don't have this. I don't have an absolute number in terms of, would have to be the distance between, so I'd have to find the distance. So I'm gonna use a util, right? I can use the distance, right? The util distance between these two things, or whatever. If the util distance, right, the distance between one and the other, and I can just put that in there. So here's the util distance. If the util distance is less than, let's say, 3, right, and I'm going to make that absolute. Let's add that in. Absolute value of the utility distance of the distance between the two things is less than 3 pixels, approximately. I'm using the built-in ABS function, right? Math. Then stop. Let's see if that works. That's also going to mess things up. Watch, you're going to see how that works. So if I press patrol path, let's try it. And it's going to go here, it's going to spin, it's going to go here, it's going to go back here, and then boom, and then it's going to go back and correct itself. So that works, and the reason why it works is because it's close enough. That's how it's going to work. And you can put whatever kind of weird patrol path you want in there to do it. Okay? That gives you a sense of how that works. And if you wanted to do this up here as well, if this was 58, 57, 56, 55, 54, 53, 52, 51, I want to go here, there, and then back. Let's put that at 51. Let's play around, right? So you can try, these different paths. And again, I would put that inside of when I'm building up my paths, 51. So I go left, and then I want to go to 51 to kind of have that weird path at the bottom to not make it symmetrical. It's not going to look right, but it doesn't matter. So here I go. I'm going to go this way, down. It's going to shoot up, bounce in there, and then go down here, shoot back, and then back up there like that. And there we go. We can make whatever path we want. And it's going to keep doing that over and over again. Okay? So kind of neat. And you can see if you put the debug on, you can see what's happening exactly as it moves forward and back. Okay, exactly what you want. Exactly what you're looking for to do. All right, questions around this. Questions around this. This is something that we have as a base. It looks like it's working okay, and I think we've satisfied our requirements. So that's the solution to the challenge. Hopefully you guys had fun doing it. I certainly did. What I'm asking you to do now is take whatever you have, whatever you've coded for tomorrow night at midnight, and hand it in to get your lab mark. And that's what I'm looking for. Hopefully it's going to be something that looks like mine. You don't have to do these funny changes, these 51 and 58s, as long as it kind of goes in a clockwise direction or an anti-clockwise direction. I'm totally fine. And that's it for me, guys. I'm going to stop recording now and I'll take questions.